Welcome to Calculus. Being challenged has a whole new meaning. On this episode, Stevenson will demonstrate Now that we've looked at exponential functions, let's look at the inverses. So let's look at log functions. The first rule we're going to focus on is this one. So this says the derivative of log base a of u equals 1 over u times log of a times du dx. So let's quickly break this down. U is going to represent whatever function's inside your log function. A represents the base of the log. So when you do the derivative, it's 1 over the function that's inside your log multiplied by the natural log of whatever the base is of your log function. And then you take that fraction and you multiply it by the derivative, because of chain rule, of whatever the inside function is. Let's look at our first example. So y prime is, so in this case, a is going to be 5. My u is x squared. So I'm going to follow my rule here. So it's going to be 1 over u, which is x squared, so 1 over what's inside my function, times the natural log of my base, in this case it's 5. And then I multiply that by the derivative of the inside. Well, inside is x squared, so the derivative of x squared using power rule is just 2x. So if I rewrite this, it would look like that. Notice the x's can simplify out, and this would be my final answer. Now let's look at one more. So again, these can become more complicated. So it's going to be 1 over my inside function times the natural log of the base times the derivative of the inside. Now be very careful here. This is a sum, so we got to treat them separate. And notice this is 1, the derivative of 1 is 0. Now be careful, this is not product rule here. Well, let me take that back. You could think of it as product rule, but you would be like way overcomplicating this thing. This is natural log of 3. That's some number times x. So its derivative is just natural log of 3. At this point now, you can see the natural logs will simplify. And I would be left with that answer there. There is a domain restriction because of the fact this is a denominator. And remember, our rationals, so we can't have 0 in here. So x would have to be, if we look back at our original here, the log can only start from greater than 0. So you have to set the inside quantity equal to 0 and solve. And if you do that, you will end up with x has to be greater than -1 over the natural log of 3. Over here, I should have put my restriction on this one. So if I look at the original, I would just say that x has to be greater than 0, because log functions, the domain, are 0 to positive infinity. Notice on the exponentials, we didn't have any domain restrictions, and that's because exponential domains are all real numbers. So we're still going to follow the rule from above. However, notice I'm dealing with natural log this time. So if I want to find the derivative, I'm still going to follow the same rule. So I'm going to do 1 divided by u, which is x squared in this case, times the natural log of the base. Now remember, when you have a natural log, the base is e. Then we're going to take this and we're going to multiply by the derivative of the inside, which is 2x. Now do you notice something? Remember, natural log of e is 1. And I'm left with my final answer. Now again, my domain, my x values have to be all positive because of my original function restriction. Let's try this one more time, because there is a shortcut here. Did you see the shortcut? Now when I go to do my derivative here, I have to use that rule that we just covered with exponentials. Now I'm going to simplify where I can. In this particular case, notice natural log is e, but notice the 5 to the power of x, 5 to the power of x simplifies out, and I'm left with natural log of 5. Now, did you recognize what the shortcut was here? Whenever you do the derivative of a natural log function, all you end up with is 1 over the inside of the function times its derivative. That's your shortcut. Why does that happen? Because if we follow the log rule above, well, you're going to end up taking the natural log of e, and remember the natural log of e is 1. So let's look at this example. If I just cover this up, see how it's 1 over the function times the derivative of the function.